Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at the edit family command in our electrical software for Revit. If you are attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. So today we are looking at the family edit command. This allows us to add information to your families so that they work better when you're working with them in your model in Revit. So to do this, we actually need to go ahead and open up a family. To start with, we'll just take a receptacle. Click on this family, and we actually do need to edit the family. So we'll click on that instance. Run in Revit the edit family command. That'll open up the family here in Revit. And then on the DM electrical tab, you'll see that the list of commands has changed. Gotten rid of most of them because we're looking at a family, but we do have the new family edit command. So that's what we're going to be talking about today. When you run the family edit command, it opens up this family edit window. And so it's broken into two pieces. Up in the top, we have the family settings. In the bottom, we have the type settings. The idea is that most of your settings you can put up in the family settings, and that will apply to every instance of that family. You can then also override anything at the type level. So families have types, which are the different types of that family. For this receptacle, we've got GFCI and a standard. So we could set up some different values based upon the type, or we could have everything set just based upon the family. In the family settings, we have the device type. There are two main types of devices in Design Master. We have the branch circuit devices and the distribution equipment. Branch circuit devices correspond to everything that's connected to a panel, your light fixtures, your motors, your air handlers, your receptacles. That's all the branch circuit devices. Distribution equipment is your panels, transformers, everything that has something else connected to it, essentially is what we consider distribution equipment. If it's the last thing in the line, that's a branch circuit device. If it has other stuff connected, that's distribution equipment. And that's the distinction that we make in our software pretty consistently through everything that we're doing. So when you specify your type, you get to choose for the type what the device type is. If it's a branch circuit type device, and then there's a couple options, and then distribution equipment. If you're defining it with our software, you do have to define what this is. If you don't set this up, our software will kind of figure it out based upon the Revit type. If it's a branch circuit device, if it's electrical equipment, we'll assume distribution equipment. And then we're just going to pull default values and let you set these values yourself. So you don't have to make any of the changes that we're talking about here. The reason we're making these changes is it actually makes things work a little bit better and smoother when you get into the project, and you don't have to make as many changes there. We'll stick with branch circuit device other for the moment because this is a receptacle, so it's not really an equipment connection. Then we have some options here for the device that we can specify that are then going to get transferred to the project. The first is the circuit description. There are two ways you can do circuit descriptions in Design Master. You can let Revit control those entirely, so you can leave it up to Revit, in which case this isn't going to be used anywhere, so it doesn't matter what you set. You can also have Design Master control your circuit descriptions. And if you do that, then our software is actually going to be filling this in. And we have a slightly different paradigm for how this works from how Revit does it. We like to think ours is an improvement. Different people have different opinions on that. So you have the option to use ours. The nice thing about ours is that you can, in the family, set these descriptions and have them come in nicely in your project. So we're going to change this description to be receptacle. So now all instances of this device would have that as the circuit description. Just as an example of our type settings, we'll go ahead and change the circuit description for our GFCI receptacle to be GFCI. So now this standard is going to use the family setting, so it's going to use the receptacle description. And then if we change it to a GFCI type, it'll actually use the GFCI circuit description. We'll click OK to save those settings. We've made those changes in the family. We need to load that into our project. So we're going to do that. and get that pulled into our Revit project here. I'm going to check my customization and make sure we're using our Design Master circuit descriptions. We are. So under options, we have the circuit description using the Design Master ones. So those changes are going to get seen. And now if I select this receptacle and run circuit edit, it'll pull it up in the circuiting dialog. And you can see that that circuit description is now being filled in here based upon that receptacle. We've also got some GFCI receptacles over here. And so it pulled in that GFCI receptacle setting. So we're pulling in the description into Revit for you automatically based upon that family. So if you swap out the family and connect it to the circuit, it'll pull that in. And then also just pulling in the room name based upon this setting here. It's pulling in room names automatically. So that's what the circuit description allows you to do. You can also, just to complete the circuit description thought, you can also then override that in the instance. And this will be true of most of the settings that we're looking at. Right now, we're using the description from the family. We can set it in the instance. So if we wanted to, we could set this to be an existing receptacle. And then that's going to push out into the description here in the circuiting. So we have the existing receptacle and then also some other standard receptacles being added here. But the base level for the circuit description is actually set in the family edit command. So that's the circuit description that we have. There's also the load. This is just a display value. You can't actually change that here. This is just displaying what the load is in the family. We're pulling that from the connector in the family. So we're just displaying the information that you've got set there. If you want to change that, you actually come out here and on the connector, this is where that value is being set. So that's just a Revit parameter that we're displaying in our dialog. You can specify whether or not to include an isolated ground or not on this device, again, in the family or in the type. Then you can specify for the one-line diagram, the overcurrent protection and the feeder ID graphics. So by default, we're going to use the default feeder ID. We're going to use the overcurrent protection from the upstream device, but we can override that if you happen to know that this piece of equipment always needs a fuse or something else. You can make that change here. And then when you insert it in the one line, it's going to pull in that graphic for us. So if I change, I'm going to leave it as use upstream device equipment for now. Let's actually insert this in our one line. So we'll link this device to our one line. We're going to do just an equipment connection, put that over here. And when we edit it, you can see that the overcurrent protection is using the family default, which is just pointing to the upstream equipment graphic. We can then go into the family, run the family edit, and let's actually change the value now. So instead of using our circuit breaker, which is the default, let's use a fused switch. And let's change the feeder ID graphic. I don't remember if we have hexagons or rectangles, but we'll change it to oval. And we will then load that into our project, overwrite our settings, go back to our single line diagram. And if I redraw this feeder, it'll update. If we did if you ran a calculate, that would update it as well. That'll take a little longer. So now it's pulling in that different overcurrent protection and the different feeder ID. So if you want to have those set at the family level, if you always know it's going to use a different type of overcurrent protection, you can set that in the family. So those are the settings that we have for just kind of generic branch circuit devices, kind of receptacles, light fixtures, things like that. We also have the ability to specify this as an equipment connection. And for this, I will open up a different family. We're going to take this cooling tower that we have here that's all wired up properly. We'll edit this family. And we'll run our family edit command. And we're going to change this to an equipment connection. I'm going to change my circuit description just so it comes in nicer because we're going to be looking at that. Now we have all the same settings, overcurrent protection, feeder ID, and then we have some additional information. You have the toggle for whether it's going to show up in the AutoCAD one line. We're kind of phasing out the AutoCAD one line, so hopefully you're not using that at this point. And then we have the FLA, the MCA, and the MOCP. So you can specify all of that in Design Master, and then you can use those or other values to size the overcurrent protection the conductor for the piece of equipment, and also specify your motor values that are going to be used for fault analysis. So the FLA, MCA, and MOCP, these are values that you can input. Set our MCA to 50 and our MOCP to 100. Those are then really just going to be kind of output values. So if we click OK and we load this into the project, on this piece of equipment, those values will get pushed out to the device has the equipment MCA and MOCP. So we're actually filling in these values here based upon those values from that setting. So we can then use these if you need to use them for other purposes, other scheduling. You just have them for scheduling purposes. We can also use them or other values for sizing the breaker and sizing the wire. So for the OCP Trip, we have the option to size it a couple different ways, depending on if you're using a motor compressor, which is NEC 440, or an actual motor, which is NEC 430. So we've got a couple options. If you're using the motor compressor, it's based on the MOCP. Motors are based on the FLA. So you can specify what the breaker size is based upon either the MOCP or the FLA, based upon which type of device you have. You can also do a custom trip size where you just type in, this is the breaker size I want to use. So if you don't want to have it sized based on anything, you can just say, I always know that this piece of equipment needs this size breaker. So you can do this at the family level. You could also have multiple types. Again, I think this one, it just has one type. But if you had multiple types, multiple different sizes of equipment, you could have them set out with their overcurrent protection specified in each of them. For now, we'll size it just to match the MOCP. And then we can also specify the conductor size. We can size it automatically. It's going to be based upon the breaker size or based upon the load. If the OCP is a motor, then it's actually going to base upon the loads. So there's a little bit of subtlety there into how we're going to do that based upon actually what this setting is, whether it's a motor compressor or a motor. And then we can also size it based upon the MCA, based upon the branch circuit selection current, which is the FLA is also the branch circuit selection current. You can size it based upon the loads in the device or based upon the breaker. So you can call it out specifically which of those two you want to use. And then finally, you can just type in a custom conductor size. If you use a custom conductor size, it does need to match up to a conductor that exists in your project. Actually, no, so you specify the ampacity essentially, and then it finds the corresponding conductor size. So you specify the ampacity and it chooses a wire size matching based upon your wire ampacity settings. So we'll do it based upon the MCA, load that into our project. And now if we look at the circuit that this is connected to, we have that 100 amp breaker and a 50 amp wire being used. So that's what those are going to be using for the sizing. It's going to be pulling that from the family. So you can set that at the family and then it's going to use that automatically. In the same way, we are overriding our circuit description, and we can also override these values at the instance level. So all of these values give you your default family values, and then you can use instance edit to override them as appropriate. So if you need to, you could come in here and give it a different MCA or a different MOCP. So those are giving your default values always, and then at the instance level, you always have the ability to override that. And then the motor multiplier and the motor XR ratio, those are actually fixed because so if you set those, we do fix those in the family. And so those are being used then for fault analysis, where we're and for the voltage drop, finding the impedances. The 4 and the 5 values are typically pretty good defaults, but if you happen to know what they are and you do want to override them, you can do that. So that's branch circuit equipment. We've got the generic devices, and then you've got the equipment connections. We also have the distribution equipment. So we'll go ahead and open up a panel here. When we run family edit, we can then specify distribution equipment. So other is just something that's not a panel or a transformer, and it's going to give you some default options. And then the panel and the transformer have these options and kind of extend it from here. The first is the prefix or a suffix that you can add to the upstream description. So again, this is if you're using our circuit descriptions. By default, we fill in the just the name of the panel in the upstream. But if you want to say this is going to be panel so-and-so, you can add a panel prefix. And if you want to add additional information on the suffix, you can do that. Maybe for the specific size, you can say 125 amp bus, just so that might be something that you want to put in there. Maybe not, but just you could put something as a suffix as well. Then you can specify what the neutral is going to be. By default, we use same as phase, but you could also double the phase or not have a neutral if you don't want it, or you could have a custom neutral size. Same with the ground. We can size it automatically or size it based upon the equipment or service ground, or not have a ground for this piece of equipment. We'll leave those settings as they are for the moment. Actually, since this is a panel, we'll go ahead and change it to a panel as well. So now we get a couple more options. We'll take a look at those. So we'll load this up into our project. If I do my panel edit, you can at least see the description. It's got that prefix and then that suffix happening in that description. So that's where that's showing up, and that will then transfer up into the circuit description in the panel schedule as well. We also have the bus size, the disconnect type, and the disconnect trip and frame. So here you can specify for your panels what the bus sizes and your disconnects are. So if you're specifying that this is a panel in Design Master, you kind of need at the family or type level to specify this information. This is why you would use this mostly for a panel. Revit has the mains and the disconnect actually completely backwards. They allow you to change the mains, but not the disconnect at the instance level. We do that the other way. The mains is kind of a fixed value of the property, and the disconnect, you have a default, but you can't override it because you can swap out a breaker essentially. But the mains is kind of a built-in part of that of the panel. That's the size of the panel. So this is where the different types come into play a little bit more, where you could come in here and say, okay, this is a 125 amp panel and this is a 400 amp panel. So if you change the type, it's also going to change the mains value. So this way the type sometimes will also change. This will change the geometry of the panel. So you might get a different size panel based upon that bus size. And then you'll also have the bus size updating in the software. And then we can change it to say this actually has a main disconnect. We'll set it to be a breaker. It's going to default to be the same as the bus size. And then you can override that in the project. So we'll click OK, load that up into our project. And then if we run panel edit, at this point, the bus size is now 125. And we call out, hey, this is set in the family. So you can't change this here anymore. If you want a different bus size, you actually need to choose a new type in Revit. So if I change this to the 400 amp, we will then get the 400 amp bus. But that's really being set in the family, so you can't change it here anymore. The disconnect type, it's not pulling the, let's go make sure that's set right. Because I wanted to have that as a main disconnect. And I think, yeah, so I've got that overriding here in the types, so I need to set that to be a main breaker here. So now it sees that it's got the main disconnect type as a breaker. Default is the same as the bus size, but we can override that. So the bus size, when you set it in the family, is then a fixed value. The disconnect type and trip have default values, but you can override them because you can, in the real world, you would be able to do that. So that's what you have for panels. And now let's go take a look at a transformer. So the transformer doesn't have all of the mains and the disconnect options. Instead, we have the size of the transformer in kVA, the K-factor rating, and then the impedance and XR ratio. So this is where you can specify all that information at your family so that when it comes into Design Master, it knows what's going on with that transformer. In this case, you actually would at each type really want to override the values and say, okay, this is a 3 kVA transformer. And then, based upon that size, you could set the impedance and the XR ratio. And so we come here, set this to 6 kVA. So it's a little bit of work to set it up ahead of time. But the idea is that then when you use this transformer, it's going to have that and know that information. So I'll set this to be 9 kVA because these are not values that we have in the software by default, 15 kVA and 30 kVA. So click OK. I'm going to go over to the project real quick before loading it. So I haven't loaded those changes yet. If we select this panel and we run the panel edit, really the transformer, you can say that we have the kVA here and we can actually change it. So we can specify what this kVA is. It's not telling us because it doesn't know, because Revit doesn't have that as an intrinsic property. So we can specify it as a 15 kVA transformer to match that type. So that's kind of out of the box how it works with families if you don't use the family edit command. So now using the family edit command and loading these changes that we've made into my project. Now, based upon the type, it's actually going to be specifying that kVA. So if I set this to a 6 kVA transformer in the type with all the changes that has, geometry-wise, otherwise, in the panel edit, the kVA here is 6. And we can't change that because that's being set in the family. If we need to change that kVA, we would choose a different transformer here. If we set it to a 30 kVA transformer, it's now a 30 kVA transformer. And that's being based upon those values being pulled from the type. And then that will work in the same fashion for your K-factor rating and your impedance and your XR ratios. So we have impedances for just kind of a standard transformer that covers kind of a conservative case. But, if you actually have real impedance numbers and you want to get those into your fault and into your voltage drop calculations, you could specify those. If you have a specific manufacturer, you've got the cut sheet, you can come actually type in those values. And then you have a nice family that you can use that has those impedance values set for you. So this is the way to get impedance values loaded in the software that are different from our defaults, is you specify what the values are actually here. And then the XR ratio, again, we use that in those calculations. Transformers typically are about 5, but if you know differently, you can specify here, and then that'll feed into the rest of our calcs. And that is how the family edit command works. The idea is that you can take your families, add a little bit of additional information to them, so that's getting loaded up in your projects automatically without having you to make that change in every single instance in the project. With that, are there any questions related to family instances or anything in Design Master Electrical for Revit? Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.